Today's lesson is on chapter 10, lesson 2 on multiplying fractions. We're going to find the product of two fractions. What does product mean? Product. Got them.
The answer to a multiplication problem?
Correct. The answer to a multiplication problem. So we have two fractions. Yesterday we worked with whole numbers and fractions. Today we're working with two fractions. Yesterday we learned how to model it using pictures or fractional parts. Today we're also going to learn that, and also you can also use the mathematical way. So let's look at the example. Can you read that for us, please?
A class spent 3/4 of an hour practicing for a play. They spent 5/6 of the time singing. What fraction of an hour did they spend singing? To find a fraction of a fraction, you have to find the product of the two fractions.
Okay, so we need to find 5/6 of 3/4. This of means what? Multiply, okay? Another way of saying multiply is using the word of, okay? Or you can say 5/6 and then use the multiplication symbol and 3/4. So there's three different ways that you can solve this problem, okay? Way one is the one that we learned yesterday, which is using pictures, okay? So way one is to use an area model. So you're modeling what you know using pictures, okay? And you're going to use horizontal lines to divide it into 6. So let's draw a big square here. And we're going to use horizontal lines to have 6 equal parts. Okay? And then we're going to use vertical lines to divide the square into fourths. So 1, 2, 3, 4. Okay? Why did I divide it into two different types of fractional parts? Why did I do that? Ashika?
You divided because you had two denominators, 6 and 4.
Right. I have a denominator of 6 and I have a denominator of fourths. Okay? So I need both of them to be represented in this area model. So if I'm doing 5/6, I'm going to use one color. Let's say, let's use red to shade the 3/4. So I'm going to shade this red. 1, 2, 3 of my 4 vertical parts. Then I'm going to use blue to shade 5/6. So 1, 2, 3, 4, 5. Okay, of my possible 6. Now, when I look at this, what part is overlapping? So this was broken up into fourths, right? And from here to here is 3/4, and from here to here is 5 out of the 6 parts. Okay? So how many boxes are overlapping both red and blue? Let's count it up. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I have 15 out of a possible what? 24, because this is a 6x4. Think of array models. Okay, area models, 6x4. So out of a possible 24. Now, is that in simplest form?
No.
What can I divide each side by?
3.
Divide each by 3. 15 divided by 3 will give me
5.
and 24 divided by 3 will give me 8. So look back at the question. The question was asking you for how much time did they spend singing? So they spent what? 5/8 hour
Is that of an hour?
of an hour. You could say hour because hour is singular, right? You're not saying hours. 5/8 hour singing. Okay. So when we looked at chapter 9 and you were adding fractions, right? And I added a fraction like 1/2 and 1/3, the answer is greater than 1/2 or 1/3, right? So you're going to get an answer that's bigger than what you started with. When you're multiplying fractions, I have 5/6 of 3/4. My answer ends up being what? Smaller. Well, why is it smaller? You're multiplying. Usually when you're multiplying, you're supposed to get a bigger product, right? But not when you're dealing with fractions. When you're multiplying fractions, the reason why you come out with a smaller fraction as an answer is because you're taking a fraction of a fraction. So you only have a fraction to begin with, and then you're going to take away from that fraction, so you have even less than you started off with. For example, if I had half a candy bar, right? I had a wonderful Snickers bar here, and I ate half of it, but then my brother came along and he said, hey, I want to eat some of that too. And I'm like, well, it's my candy bar. I already ate half of it. This is gone. And you want to take my other half that's left. I'm like, how about we split that half? Okay? So then I give him the other half of that, right? So I'm taking half of a half. So does he get a lot of the candy bar? No, but he still gets some of it, right? But a smaller portion. But I'm taking half of half, or 1/2 times 1/2. Does that make sense? So I take what I have, and I'm even taking away more from that, so obviously it's going to be a smaller amount. All right, so let's look at way 2. We touched on this a little bit yesterday, okay? And this is just multiply, then simplify. A lot of you guys yesterday, you were asking, can I do this for my problems? And I said, well, you have to understand the area models first, then you can do this method. So same problem, right? 5/6 times 3/4. All you have to do is multiply the numerators together. So that is 5 times 3. Then I multiply the denominators together. 6 times 4 across, okay? So what is 5 times 3? 15, right? And then what is 6 times 4?
24.
Very good. Now, can I reduce? Yes, they can both be divided by 3. That gives me an answer of 5/8 of an hour singing. So this is way 2. I kind of introduced this a little bit yesterday, right? Okay. And then we have another method, way 3. And you guys may prefer this one. Same problem. This time you're going to simplify using prime factorization. So think back to the beginning of the year. So I have 5/6 times 3/4. Okay? So 6 and 4 are they prime numbers? Are 5 and 3 prime numbers? So I can't do anything with the 5 and the 3, okay? So I'm going to leave 5 and 3 on top, okay? But I know that 6 and 4 can be broken down, and you can prime factorize 6 and 4. So 6 breaks down into what? 2 times. And 4 breaks down to 2 times 2, right? So I'm going to write that here. 2 times 3 to represent the 6. And then I have 2 times 2 to represent the 4, right? Now, I'm gonna simplify, and I'm going to look at my numerator, and I'm going to look at my denominator. Do they have anything in common? Do they have any numbers in common? Everyone? 3, right? So if they have the 3 in common, I can get rid of the 3. Because if I have something on top and I have something on bottom that's the same, I can eliminate them. They cancel each other out, okay? So if I get rid of the 3 and the 3, and they essentially become 1 and 1, does 1 affect my number? No, right? It doesn't affect it. So then when I do this, all I'm left with on top is what? 5. And all I'm left with on bottom is 2 times 2 times 2, which is 8. And I get my answer. Now, there is another way of doing this, and you can, instead of writing out the whole prime factorization like I did, you can do it another way, okay? So let me show you that. So using the same method, right, as prime factorization with the 5, 6 times 3/4, okay? Instead of writing out the whole prime factorization and doing all of that, I'm going to look at my numbers and I'm going to look at what they are in their cross sections, okay? Like this, okay? And see if I can reduce from there. So can the 5 and the 4, am I able to reduce from there? No. Am I able to simplify? No, right? What about the 3 and the 6? Yes. What is their GCF? 3. So that means 3 becomes 1 and 6 becomes 2. Then I go back to way 2 and all I have to do is multiply across. So 5 times 1 is 5 and 2 times 4 is 8. So I still get 5/8 of an hour spent singing. Okay? So you could do it this way. Essentially what you're doing is you're finding the prime factorization and you're eliminating it in the problem by looking at the denominator to the numerator of the opposite factor. Okay? Yes.
What do you do?
Okay, so take a look at number 1 on page 213. We have the problem 2/3 times 3/5. Okay? So if I used way 2, I would just multiply across and then reduce. So 2 times 3 equals 6, and 5 times 3 equals 15, right? Do they have a common factor that I can divide by?
Yes.
What is that common factor?
3.
3. So dividing by 3, okay? So 6 divided by 3 equals? And 15 divided by 3 is? So 2/5 is my answer. Okay? Could I have done way 3?
Yes.
Yeah, then I could have eliminated the what?
3.
3 becomes a 1, 3 becomes a 1, and then I just multiply across and I get 2/5, right? I could have done it that way too. All right, let's look at number 2. We have 3/8 times 4/5. Okay? So let's try way 3 this time. So 3 and 5, can I reduce there? No, right? But what about 4 and 8? Can I reduce there? Yes. So what does 4 become? 1. And 8 becomes 2. Now I multiply across. 3 times 1 equals?
3.
And 2 times 5 equals?
10.
Is it in simplest form?
Yes.
All right. Okay, so let's look at number 3. We have 5/6 times 3/10. I'm going to draw an area model for this one, okay? So I have here 1 square,
6 times.
and I'm going to, horizontally, I'm going to split it into 6 parts. 1, 2, 3, 4, 5, 6. And then vertically, I'm going to split it up into 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, then I'm going to shade it. Here we go. Black for 5. Oh, let's not do black. Let's do blue for 5, 6. So 1, 2, 3, 4, 5. Okay. Then for 3/10, I'm going to do green. 1, 2, 3. So how many of these are overlapping?
Wait, what is it? What's the fraction for that?
3/10.
No, I mean that's what.
5, 6. It's in your book. Okay, so how many of these are overlapping? Let's count them together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I have 15 out of a possible what? This is in tenths,
60.
and this is in 6. 10 times 6 is 60. Can I reduce 15 60ths?
Yes.
What can I divide each side by?
15.
15. Very good. 15 divided by 15 is?
1.
And 60 divided by 15 is?
4.
1/4. Okay, I fixed my model. I added on 2 more rows. Sorry.